let's get this done. Look at the warm-up. Quiet mode, please. Quiet mode. Quiet mode. Quiet mode. Looking at problem number 1, was that geometric, arithmetic, or neither?
Geometric.
It's geometric. Why? Because I said. Can I make this bigger? Can I zoom in? Haven't figured out all this stuff about this yet. I want to make it bigger. Okay, because get rid of this garbage. I'm writing on it. Yeah, it doubles every time. Yeah, from 3 to 6, from 6 to 12. Every time it doubles, that's geometric. All right, what about number 2? Geometric, arithmetic, neither?
Arithmetic.
Yeah, this one is arithmetic. It's not as obvious as the other one. So if necessary, you might want to do this. All right, Graham, make sure you pay attention, buddy. If you think it might be arithmetic, then what you want to do, you know how when we do geometric, we can do each term divided by the previous term. So I can do, 6 divided by 3 and 12 divided by 6. And those should be the same. In this case, they were all 2. Like this one gave me 2, this one gave me 2. Let me make this bigger. Okay. We can do something similar when we suspect that it's probably going to be arithmetic. If we think it's going to be arithmetic, we can take each term and subtract the previous term. So for example, if I go 1, whoa, it's crooked. If I go 1 minus 1/3, put that in your calculator real quick. Everybody needs to have their calculator out. Use it a lot. Yeah, common sense, okay? If you take a whole pizza and you subtract 1/3 of a pizza, how much of the pizza is left? 2/3.
4 4/6.
True. But we'll reduce that to 2/3. If I do that again, I'm doing each one minus the previous term. So do this. What if I do 5/3 minus 1? I'm doing a term subtracting the previous term.
2/3.
Again, I get 2/3. So if you're shooting for arithmetic, subtract. Take a term and subtract the previous term. If it's the same every time, arithmetic. Instead, if it's geometric, you take each term and divide by the previous term to do it. So that one was definitely arithmetic. Its common difference is 2/3. Do you see it now?
Yes.
Yeah.
What about number 3?
Number 3 is
Change this color.
neither.
Number 3 is neither. Nothing works. So number 2 is arithmetic, but number 3 is neither. Okay, genius. Any questions on 1, 2, 3?
No.
Now look at number 4. Find the sum of the series. Okay, I can make this easy for you.
Thank you.
Look at problem number 4. Let's just use I'm going to show you 2 different methods for this, okay? But when there are not too many numbers, it's easiest just to use a TI-30 and do it by hand. This is what I'm saying. Turn on your TI-30 and go ahead and hit the table button. Okay? So in your table button, you're going to go ahead and type in y equals 2x plus 5. Okay? So what we're shooting for is just simply having a table.
Where's the equal button?
If you hit the table button, and you automatically equal sign sitting there.
Isn't the I
I don't have my calculator software installed yet because I redid my whole computer. So that's otherwise I'd be showing you right now. I'm still working on that.
Why is the I?
That's why I don't like to use I. It's just all about context. In this context, it just doesn't mean much. I usually use K or J. Okay? So, do you guys remember when you see notation like this with this? This is the letter sigma, the capital Greek letter sigma. When we have like I equals 1 here at the bottom, does anyone remember what that means? That's the first number. It tells you where to start. In other words, when we make our table of values, it's telling us to start at an x value of 1. What does this number at the top tell us, this 5? Right, it tells us where to stop. We stop at the 5th number. So when you look at your table on your calculator, that means we're going to do 1, 2, 3, 4, and 5. I need to leave more space, but you see it. Okay? So can you go ahead and tell me what these 5 values are?
7, 9, 11, 15.
Yeah, 7, 9, 11, 13. Didn't leave no space.
I got that far, but I didn't know.
You got that far. Well, this sigma notation, it means just what it's saying here in words. Sum. What does it mean? What does sum mean? It means add. So simply take the 5 y values that we just found and add them up. Add them up. What do you get when you do that? 55.
Oh, that's it?
That's it.
Oh, no, no.
Okay? So for number 4, that's definitely the fastest way. Just put it in your calculator and add them up. Question? Sometimes you fake me out with the
No,
hand.
yeah. Are you gonna? What if like you don't want to type in all 9 things to the next one?
Yeah, that's why I'm going to show you the other way. In fact, you're going to want to know this other way that I'm about to teach you. Because what if I put 50 instead of 5? You do not want to have to sit there adding up 50 numbers, because you'll probably type something wrong at some point and get the whole problem wrong. Instead, you want to use this other method that I'm going to show you right now. I feel like I need more space though. Do I? Maybe not. There's a formula for finding the sum when you have arithmetic. Hey, you know what? In my other class, they weren't sure of this. Can you guys tell that these are arithmetic? These 2 problems are both arithmetic? Do you have any idea how I know that they're arithmetic?
Yes.
Why do I know they're arithmetic? Here's how I know. Let's see if I can I get new paper? Give me new paper. Let's go, create, make it happen. Okay. Okay, here's the deal, my people. Arithmetic. Arithmetic problems are always linear. In other words, y equals mx plus b. So when you look at this problem, when you see 2i plus 5, can you look at that and kind of see mx plus b when you see that? So when you see that it's linear, like 2i plus 5 is linear like mx plus b, that's how you know it's arithmetic. If it's linear, it's arithmetic. When you look at problem number 5, it's sort of backwards, but it's still linear. Couldn't I easily write this problem? Why does my pen keep going away? Come back, pen. Yeah, fail. There we go. Couldn't I write this as negative 6i plus 5 very easily? It's just backwards. But it's still linear. It's still mx plus b. So it's arithmetic. On the other hand, by contrast, if it's going to be geometric, this is going to bug me if it keeps doing this. Geometric is exponential. So remember, if I have something of this form, like a b to the x power, if I see something like that, geometric. I know it's geometric based on the form of the equation. Then that's no good. Okay, anyway, the formula I'm about to show you only works for arithmetic. That's why I had to mention about that. So here's the formula. If I want to find the sum of the first however many terms, n terms of a sequence or series, I could use this formula. And this is not new. I taught you this before. It's going to be n times, and I used to say the average, n times the average. But I'll go ahead and say now, we would always do the first term plus the last term. And if it's the average, what am I going to divide by?
2.
divided by 2. Because that's how you find the average of two things. You add them up and divide by 2. So this is the formula for finding the sum of the first n terms of a sequence. So if I have 9 or 15 or 20 or 30 things I want to add, I'm probably going to use this formula instead of adding them all up by hand. So let me show you what I mean by that. So in this particular case, so keep your eye on this formula. N times first plus last divided by 2. Luke.
Ooh, you're in so much trouble.
Yeah, you totally understand this? You don't need to see this? Smart move, brother. Okay, so look at this problem. Alright, let's see if I can scroll down. I need more space. Okay, so I'm going to use the formula for this one. I want to find the sum of the first 9 terms. So, S9 means I'm about to find the sum of the first 9 terms. In the beginning of the formula is n. In this case, that's just going to be 9 because I want 9 terms. Okay? So I'm just going to do 9 times. Now in here I just do the average. The first term plus the last term divided by 2. So all I really need is, I need to know what's the first term and what's the last term. Okay? So you have two choices depending on how comfortable you are with arithmetic. You can still put the formula in your calculator. And then just scroll to term 1. That'll be the first term. You can scroll to term 9. That'll be the last term. Did anybody already have this in your calculator? Did anybody do it this way?
I did it that way. What way?
Did you scroll in your calculator? Or, if you're good at just arithmetic, if I want the first term, just plug in 1. If I want the 9th term, just plug in a 9. To me, that's even quicker. So,
First term is -1.
yeah. Let me erase this little piece because that's a... Look at the original equation. 5 minus 6i. If I is 1, if I want the first term, that's just going to be 5 minus 6 times 1. That's going to give me the first term. Can you guys see that that's going to be -1? 6 times 1 is just 6. So I've just got 5 minus 6, so that's -1. So I got my first term. I just plugged in 1. You cool? Now, if I want the last term is the 9th term in this particular case. Well, if I want the 9th term, I will just plug in a 9. So for my last term, that's going to be 5 minus 6 times 9. I heard that was -49. So plus -49. And then just put that expression in your calculator. So typing in that expression is far faster than adding up 9 terms or 15 terms or 50 terms. It's much, if you understand the formula, it's much quicker to use the formula. So type that in your calculator though. 9 times 1 plus -49 over 2. Tell me what you get.
Awesome, not doing it.
Pretending to do it.
I should know what that.
Can you get,
We're all tired, brother.
can you get people their grade sheets?
Yep.
They didn't
Oh,
yesterday?
yeah.
I'll make sure I especially hand them out. Yeah, I like it. Okay, so -225. Okay, is that what you got, my brothers? What about you, kid? Okay, so that's it. That's the fastest way to do it when there's a bunch of numbers. -225. Okay, moving on. I'll come back to this thing with the formulas. I'm going to come back to that later. Now look, here comes some review for you guys. Review. Look at these examples. Let me have more space. Okay. what are we supposed to do? We're supposed to find the rule for each one of these things. Now, if you were spacing out yesterday, because we were all tired yesterday too, okay? But eventually we got to learn something. We got a quiz on Friday. Pay attention now. These 4 problems will basically once again teach you what you should have learned yesterday. If you don't pay attention again, then you still won't know it. So here we go. I'm going to go through it fast because this part is reviewed. So really focus. Ready?
Yes.
Okay. Anytime we're finding the rule, the equation for these geometric, we're going to use the same formula over and over again. We're going to keep using the formula that goes like this. AN, who knows the formula? A1 times R to the n minus 1 power. We're going to use this for all 4 of these problems at some point. Okay? So, when we're doing these formulas, this means there are 2 things that we need. We need A1 and we need R. Those are the 2 things we're trying to find. Do I immediately know one of those things right now? Sure. What's A1 right now? We immediately know A1 is 6 because that's the first term. So far that gives me AN is equal to 6 times to the n minus 1 power. Now all I need is R. You should be, if you know your stuff, you look at it and within 2 seconds you know what R is as well, don't you? No? Let me pick on you. What's R, man? John? No, are you saying it because she said it, or can you explain to me why? True, okay? Get in the habit of thinking of it as a division problem, though, okay? Think of it as 42 divided by 6. Each term divided by the previous term, that's your R. So can everyone that was hesitating, can you now see that the R is 7? Is that clear? Okay. So there are 2 things we needed, A1 and R. We found them both, so we're done. That is the equation. Okay? So that's the equation. Now this other half of the directions I'm only going to do once because it's really the same thing over and over again. The directions say then find A8, the 8th term of the sequence. How am I going to find the 8th term? Just plug in 8. If I want the 8th term, just plug in 8 for n. I'm only going to do this once though, okay? So if I want to find A8, the 8th term, I will do 6 times 7 to the 8 minus 1 power, or the 7th power. Can somebody who did this just tell me the answer maybe?
I got 4941258.
I heard it was 4941258. 4,941,258. That's how you do that. Any questions on example 1? Okay. Each one of these examples is a little bit different. Put them all together and you'll understand everything from yesterday. So let's go ahead and do example 2 now. Example 2. What are the 2 things, Braxton, when we're trying to find the rule, geometric, what are the 2 things I always need to find? The first term, A1, and? Well, in this case, it's not called a difference. It's called a ratio, which we use what letter? R. The 2 things we need to find these rules are A1 and R, the first term and the ratio. Am I given one of those things immediately? We're given the ratio, okay? We're given R immediately. So all we need is to find A1. So let's use the formula just like last time. I think I'm going to change color. Okay, so here I go. AN is equal to A1 times R to the n minus 1 power. Instead of AN, I'm going to put A4 because that's what I'm given. So A4 equals A1. I know what R is though, so I can just put 1/2. Do I know what N is right now? What is it? Yeah, N is 4, okay? A4, that means N is 4 right now. So I'm going to have 4 minus 1 power. Okay, but at this point, I'm going to replace A4 with something. Brooke, what am I going to replace A4 with right now? Excellent. I'm going to replace it with -5 because that's what it is. Look, A4 is -5. So this becomes -5 equals A1 times 1/2 to the third power. Now I just need to do 1/2 to the third power. Do you feel like you could do that in your head, or do you need a calculator? Could you do 1/3, 1/2 to the third power in your head, or do you need a calculator? Right, if you don't know how, you can always use a calculator, but let me show you why you should all be able to do it in your head. You shouldn't need a calculator to do this. Do you know what 1 to the third power is?
3.
Everybody always says that first. What's 1 to the third power, you guys? Isn't it just 1? Because 1 to the third power is 1 times 1 times 1. So that would be 1.
1/8.
So 1 to the third power is 1. That gives us the numerator. And then what's 2 to the third power? 8. So do we really need a calculator for that?
Yeah.
No. So silly. So we did 1 after the third power, we get 1/8. If you need a calculator, hey, use it. Left it at his house. So far we have this. Now our task was to find this A1 so we could write the formula. How will I get A1 by itself at this point? We're going to divide. Exactly. We're going to divide by 1/8. Change colors. Let's divide both sides by 1/8. Taste the rainbow. What is -5 divided by 1/8? Correct. That gives us -40. So -40. Okay, so there we go. A1 is -40. And we were given R in the first place. It's up there somewhere. R is 1/2. So now we can write our equation. That means AN must equal -40 times 1/2, running out of space, n minus 1 power. Okay, so there's the answer right there. Any questions about that? We're good? Are you worried? Quiz Friday. Okay, let's do example 3.
What about 8?
Yes, just plug in 8 and that'll give it to you. Anybody want to just blurt out the answer? -5 over 16. I need space for this. Alright, -5 over 16 should have been the A8. Alright, let's go ahead and do example 3. Okay, well we have A1. Brooke, when we're trying to find the rule, what are the two things that we always have to find? The ratio and the A1. That's what we always need. Well, look, we're given the A1. So all we really need to find now is the ratio. Okay? So watch this, you guys. We're using the formula, the same one for a third time in a row. We're using the same formula. AN equals A1 times R. The n minus 1 power. That's the formula we use over and over again for this. But what am I going to put for AN right now? AN, anybody? What am I going to put instead of AN? That's what I'm going to put for A1.
6.
What am I'm going to put 6. I always start off with A3 just so everybody can really follow what I'm doing. AN becomes A3. I'm just using this guy. And then that's going to be 150 because that's A1. I don't know R. That's what I need to find. What's N then? What's N? 3. Because the A3, that's N right there. So 3 minus 1, which of course you could just put 2. You can just go and put squared. Now I'm going to put 6 like Luke was saying from the beginning. And you can skip those steps as you feel comfortable. I just show every detail so everybody can follow me. So 6 is 150 times R squared. What shall I do now, guys? Anybody? Let's divide by 150, I hear you saying. Let's divide by 150, yep. Okay, what do I get when I divide by 150? I heard 1/25. Okay, equals r squared. How do I unsquare this r and get it by itself? Square root it. Absolutely, it's exactly what we do. Color change, color change. Let's take the square root of both sides. Do I need a calculator for this, or can I do it myself? Can you do it yourself? Tell me the answer. What happened? Somebody broke Selby. Why are you so quiet? Oh, there's a balance, I guess. I miss the sunshine a little bit. Okay. What's the square root of 1/25, you guys? 1/5. Did we need a calculator for that? No. Square root of 1 is 1. Square root of 25 is 5. So 1/5. Yes, ma'am?
When you said that, how can you put A for like the A1 thing?
Instead of what? What would you have put?
Instead of the A1.
Because, it's an excellent question. I have AN, but look what I have on the right-hand side of the equal sign.
Oh, yeah.
I have a spot especially for A1. So I'm going to make sure I put A1 on the right-hand side, and that leaves the left-hand side to be A3. Okay? Alright, so I have R now. So now I have both things that I need. Roshana, what are the two things that I need to make an equation of geometric? What are the two things that I need to find anytime I'm making a geometric equation? Ratio and A1. Those are the two things I need. I just found the ratio. I was given A1 at the beginning. So I can write the answer now, can't I? So the answer is, let's see, what was that, A1? Okay, so here comes the answer. I feel like changing colors. Let's go orange. AN is equal to 150 times 1/5 to the n minus 1 power. Boom! There it is. Questions about that?
No, I have a question for the next one.
All right, I'm about to be there. Are you soaking it in? Any questions? Let me run over you. Okay, well I have to kind of erase this.
Is the 6 supposed to be that big?
What is the A? What's A and A?
No.
Alright.
Did anybody plug in 8 and find the answer for that? 0.00192. Some kind of, yeah, what she said. Okay, here comes example 4, the last review example from yesterday. Okay? Yeah, this is supposed to be a little 6, like, it's A6. This is the one where we need that other little weird formula. It looked like this. Do you guys remember this from yesterday? I said A big equals A small times R. Thank you. Okay? This is when we use this silly looking little formula. When we have two random values that we're given. We're not given R, we're not given A1, we're just given two random values. That's when you do A big and A small. Okay? Obviously, hey Luke, you got to keep your head up, brother. I know you're a genius and all, but you still got to keep your head up. What am I going to put for A big, you guys? Yes. Of course, temporarily, I'm just going to put A6, if you don't mind. All right? And if A6 is A big, then what's A small? 1. Right. I'm just going to go ahead and put A2 for a second. And then I'm going to have R times. And of course, the big minus small that I'm talking about is simply 6 minus 2. So I should be able to get R out of this. So here I go. Just like you already told me, instead of A6, I'm going to go ahead and put 5, 1, 2, 0. Instead of A2, I'm going to go ahead and put 20. R. And that leaves me to the 4th power. Okay? Mr. Norris, can you tell me what I'm going to do now, brother? Divide by 20. Excellent. Let's divide both sides by 20. Yes, sir. That leaves me with r to the fourth power. What is this divided by 20? 256. Okay, so 256 is r to the fourth power. How do I go ahead and get r now, you guys? Right, we do the fourth root. Fourth root. Do you guys remember how we type this into our calculators? Yes, please understand that when you type this into your calculator, you guys, you type the 4 first on your TI-30. I wish I had the TI-30 on the screen here, but you type the 4 first, and then you hit second caret, and it becomes the fourth root at that point. I heard that it was 4. Okay, so r is 4. Graham, what are the two things I need to find whenever I'm finding a geometric equation? Be ready. You know r. It's close. A1. R and A1 are the two things I need. Well, check it out. I have R right here. It's 4. Do I have A1 somewhere? No. No, I still need that. So I found R. Now I need to find A1 because those are the two things I need. How do I find A1? Nah, that was funny. We'll find A1 using the same formula that we've been using. That's what I hear Greer saying back there. We're going to use the same formula that we use in all the other problems. Okay? So using this, using the whole an equals a1 times r to the n minus 1 power. Using that, this is going to become, do I use the a2 or the a6, you guys? Use the a2. Would I get the same answer if I did the a6, Greer? Yes. Why am I picking the a2 then?
Smaller.
This is smaller, easier. But just understand it's your choice. I just don't want you to look at it and get stuck and go, wait a minute, how do I know what to do? It doesn't matter. Just pick the smaller one for fun, because it's easier. So that's why I'm doing A2. So A2 equals A1. That's what I'm looking for. Let me circle this, because I'm so happy to have that. I have R now, right? What do I put in this parentheses? 4, right? Because I have it from down here. What's N? 2. Because that's 2, so that's 2. So 2 minus 1 up there. So instead of A2, like you guys already told me before, I'm going to put 20. So 20 is equal to A1 times 4. 2 minus 1 is just 1. Do I even need to put it? No. I do not. So 1, it's invisible. Last step, what do I do? Divide by 4, yeah. Whoa, I missed. Divide by 4. That way those cancel out. I heard 5 over there. So 5 is equal to A1. Okay? I needed to find A1 and R. There's A1, there's R. That's how I know I'm ready to write this answer. So what is the answer? Tell me what to write. Start off with AN equals 5 times 4 n minus 1 power. For some reason, a common mistake is for, go ahead. I assumed you were, yeah. A lot of kids will plug a number in for n. Please don't do that. For the final answer, it needs to be n minus 1. So make sure you leave it that way. Alright, so that was a nice review of what we did yesterday. Right, I said I was only going to do it once, but you plug in the 8 into a formula, you get it. Does anybody want to blurt out the answer for us? 81,920. Boom. For my overachievers. So that was our review. Now comes the new stuff. So the rest of today's lesson is all about finding the sum. Austin, face off the desk, please, buddy. Yes. We did part of it. Not G. We did arithmetic, but not
He's
geometric.
so asleep right now.
Austin, come on, buddy.
Oh, that's so funny.
Wake up, man. That's like 1.5. Yeah, don't do that again. I have to give you attention.
Put a half on the board.
We're all so quiet today.
Yes, which is good, but also sad. Sadly, it's strangely sad at the same time.
My eyes open like
Yeah, it's a gift. It's a gift. Find the sum of the first n terms of the geometric series.
I kept trying to make myself go.
Now, you guys, here's a formula. I'm just going to teach you the formula for how you find the sum when it's geometric. So watch this.
Wait, so all we just did was arithmetic?
No. Most of the last 4 problems we did were all geometric. It was all R. That was all geometric. But we weren't doing any sums. All we've done so far was finding rules. Now we're finding sums again. Yes. That's what it said on the note. Go ahead. Here is the formula for finding the sum when it's geometric. Okay? If you want to find the geometric sum, the formula is the sum of the first n terms is, what was it, a1 times 1 minus r to the n power over 1 minus r. That's the formula. It's on the front of your sheet. So you already have the formula. That's how we will find the sum, okay, when it's geometric. So, look at example 5, but keep your eye on that formula because that's what I'm going to use. Let me bring this back. Let me bring it back up. It's not going. All right, anyways, let's just go forward. So, let's see. In this formula, I've got A1 and I've got R that I've got to deal with, and I've got N. Well, we're given N, and we're given A1. Let's just write all this stuff down real quick. Boom. Okay, let's list this off. A1. What's A1 for this problem? In this particular case, A1 is 1. It's the first term. There it is. Genius. We're going to need R. How do I find R geometric? Divide. Right. For example, she said divide 25 divided by 5. Each term divided by the previous term. Okay? So in the back of your mind, you're thinking 25 divided by 5. What is that, obviously? 5. Or even more simple, we could just do 5 divided by 1 using the first 2 terms. Either way, we come up with that the R is 5. So we have A1, we have R, and we have N, don't we? Because here's N right here, 12 terms. So we'll just plug all those into the formula and use your calculator. It's simple. If you know the formula, it's simple. So watch this. We're supposed to find the sum of the first 12 terms. That will be A1 times 1 minus R, so that's 5, to the n power, so that's 5 to the 12th power, divided by 1 minus R, which is 1 minus 5. Boom! We're just straightforward using the formula. Let me see you type it into your calculator now. Go. Okay, I should see it on everybody's calculator. Come on, practice. Okay, reinforcement, brother. Yeah. Right now we're just typing that formula into the calculator.
It's a big number.
S12 equals 1, blah, blah, blah. Oh, look, just FYI, you didn't make it out. The formula is right here. This is the formula for finding the sum when it's geometric. Okay? Alright, A1, you know what that is. R, you know what that is. N, we're given it. 12. I mean 12 terms. We're just plugging those 3 things in the formula, typing it all guys get for your answer? I saw 6 million something. 61 million. 35,156. Agreement in the world? You guys agree? Anybody get something totally different?
I did, but I didn't put it in my calculator. I just wrote like step by step.
Oh, use the calculator. Go ahead and use the calculator. The step-by-step thing should work, but you got the order of operations. It's, let's just use the calculator. Would you like me to go through it and show you? Okay. Like, seriously, no. Let's not. Let's not. That was cute. Okay. All right, well, let's you know what? Yeah, we have time. Do example 6 right now. There's a competition, okay? My first class, only 5 people got the right answers, okay? Well, I won't say this right or wrong, you can see what's not about me, but I do want to come see. In my second class, like 10 people got it right. But still, most of the people got it wrong. So I want to see if even half the class can get this problem right. I don't want to say yet. Do number 6, everybody. Where's that? Oh, it's on the other page. Okay, I see your answer. I see your answer. Oh, it's like a cell. Oh, that's a cell? Racetrack? What is that? A golf course. Yeah, I'm seeing mitochondria. What?
Yeah.
R is each term divided by the previous term, right? Divided by what? Time's up!
Wait, that wasn't clear.
Well, you're ahead of me, so just keep going. And before I finish, you'll finish before I catch up to you. We certainly all have found the R by now, haven't we?
No.
What's the R, Selby?
-3.
-3. Can we all agree that the R value is -3? Are we in agreement upon that? I feel like I shall switch colors. I also feel I need more space. Computers are magical. Okay, so this is what happened. We all agree that R is -3. N is given. We all agree that A1 is 4. So I'm just going to take these 3 things and put them into the formula. So the sum of the first 6 terms should be A1, so that's 4, times 1 minus. Now, here's where you have to be careful. When you have a negative and you have a power, you need parentheses. They're not optional. I've tried to emphasize this to you over the months. A negative number with a power, it has to be in parentheses, or you will get the wrong answer. Okay. Order of operations, okay? We don't have a negative and a negative yet, because what we have is a negative minus a negative that has a power on it. You'd have to do that power before you worry about the negative and negative. Okay? So, in other words, look, here's the bottom line. Some of you have 730 on your paper, and some of you have negative 728. If you didn't have either one of those 2 answers, then you're just way, way, way off. Okay?
Let's do 1 plus 3.
Right.
Yeah, that's
If you put 1 plus 3, that's why you got the wrong answer. Okay? Because of the order of operations. You cannot do anything with these signs when it's in a parentheses with a power on it. It's trapped in there. You have to do the 6th power first. And the even power, we all know, would wipe out the negative sign. So if you just want to just type everything in your calculator, just please understand that you'd have to type a parentheses around the -3. As long as you do that, you can just type it in your calculator, let your calculator figure it out.
I didn't type the bottom.
Yeah, in the bottom you put 1 plus 3, probably.
Yeah.
Totally good and fine. As long as you didn't do 1 plus 3 to the 6th power, that's why you got 730. 730 is wrong. The correct answer is negative 728. Questions? Is anybody getting the wrong answer? Not sure why.
Mine says error on my calculator.
Help her out. Okay, I want to make sure I do one of the ones at the bottom with the sigma. Just so you can see that it's the same thing. It's no different.
Why does mine say interval?
So we'll do number 8. This will be our last problem. Okay? It's the same thing. We need the 3 things. We need n, we need a1, and we need r. For this problem number 8, can you guys tell me what n is? N